Good morning, everyone, and welcome to today's webinar. Apologies for the slight delay. My name is Carolina Haig, and I will be your host and technical support today. And hosting today will be Martin Toreskog, of course. So, just before we start now, some practicalities. If you're experiencing any issues with audio or video, it could be that your web browser isn't cooperating with Livestorm. So if you're experiencing any trouble, please try to use Google Chrome instead, as we have found it to be the best platform to use with Livestorm. But if you're still having difficulties, try to refresh the page. And if that is not working, try to log out and log in. And if you have any thoughts or questions, please ask them in either the chat that is public or in the Q&A tab. We will have a Q&A at the end of the webinar, and you will have the opportunity to have your questions answered. So now just a short introduction about us at PDS Vision. For those who don't know, we are a global software solution provider, and we offer market-leading and cutting-edge solutions that enable our customers to realize their business value within product development, manufacturing, service, and operations. And we at PDS Vision are considered the leading and trusted advisors within the product development sectors. And amongst our customers, there is Atlas Copco, Väderstad, Cargotec, and many more. But the bigger question is actually why they have chosen to work with us. One simple answer is because we care. We care about our customers' challenges and how we can help them on their digitalization journey. And the fact that we also care about being a company that makes a difference. So this is PDS Vision. We are sustainable, professional, and we have a passion for what we do. We seek to be sustainable as a partner, employer, and a company to work with. And we are passionate and professional throughout our value chain. Now that's just a short introduction about PDS Vision, and now I will hand over to Martin Toreskog.
Thank you, Carolina, and I hope that it will work as expected. Last session we had some issues. Can you confirm that you can see my screen?
I can confirm that I see your screen.
Perfect. So during last session, we covered the CAD to engineering bill of material process. And so this is the second session of the series. And we will now focus on the eBOM to mBOM to work instruction process. And in the same way as last time, I will start with some slides, and then I will focus quite a lot on working in Windchill with the demo, and then we will end with some questions. So starting with some definitions, as we did last time as well, we covered the part or item object, which is the representation of the part number and sort of the foundation of the BOM. The part or item acts as the placeholder for all related documentation, as we talked about during last session. It could be generated based on CAD or manually created without any CAD. So that generates the engineering bill of material that we can see on the left-hand side here. We can then leverage that information to create downstream BOMs. And in this session, we will then focus on the mBOM or manufacturing bill of material. And often companies have the need to create assembly levels for pre-assembly or purchased levels. And if they don't have Windchill, for instance, or a system support to manage that, they basically manually need to keep track of these changes. So in this case, I have created a part called engine assembly, where I've selected some of the parts from the engineering bill of material to add to that part. So this part is not represented on the eBOM side, but it's present here in the mBOM side. So the mBOM represents what we produce. So we define the BOMs, the parts and the BOMs that are needed for manufacturing, but we don't define anything how we do it. That's what we do in the process plan. Typically in an ERP system, this is called routing or routing. So basically the list of operations in the order that we perform the assembly steps or welding steps or whatnot. So this is how we produce it. The process overview looks like this. So it's a 4-step process where we start by creating the mBOM based on the eBOM. We can restructure that, as I talked about before. Then we leverage the manufacturing bill of material. Then we have all the parts that are needed for manufacturing. And then we create the process plan based on that, where we define the assembly steps in as detailed level as you want. We then drag and drop the parts from the mBOM into each operation to define what materials are used for that particular operation. For illustrations here, you could either use photographs or images and attach those to the operations, or you can use Creo Illustrate to generate 3D representations or 3D illustrations based on these operations. All of these steps are associative to one another. So if the eBOM changes, which it will most definitely do, then we can easily identify those changes and incorporate those into the manufacturing bill of material. And then if we introduce a new part, we have replaced a part with another one, let's say, we can then add that new part to the operation that it belongs to. And then based on that, the illustration will automatically update. Then we can publish this information. So we publish the process plan with the associated parts, with the illustrations, with the documentation and so on to the operator user interface. And Windchill has a built-in work instruction publish. So you can view the process plan in HTML or PDF. But you can also publish this to PTC ThingWorks or our own solution Significant to basically view the work orders and so on. The BOM transformer window is where we create the mBOM and do the restructuring. So we open up the engineering bill of material. We have that on the left-hand side. And then on the right-hand side, we create the manufacturing bill of material. And we can then create our own BOM levels here and simply drag and drop either from eBOM to mBOM or inside the mBOM to create the content of that BOM. As you can see in the image here, the parts that are already consumed in the mBOM are grayed out, and any parts that are not in the mBOM will be displayed in shaded mode like this. So if a part has been replaced, a new part has been introduced, then that will simply show up like this. So you can select it and then drag and drop it over to the mBOM. Then the process plan. So we leverage the mBOM and have that on the left-hand side here with the visualization. In the process plan, we then add the operations that we want to perform. And then we drag and drop the parts onto the operations. So we have the list of operations, 10, 20, 30, and so on. We have the mBOM on the left-hand side. We drag and drop, and then the parts will show up here, and the visualization will also show up. When I drag and drop a part, basically allocating a part to an operation, it will be hidden in the visualization, the visualization, and then I will simply see when I've consumed all the parts, because then it will be empty on the mBOM side. The operator user interface. This is a screenshot from ThingWorks, and we have the list of operations that you saw in the process plan. We have the list of parts for each operation. When you click an operation, the visualization will be loaded. You could add required tools for that particular operation. You can have associated documents. You can start and stop the operations, and you can also report problems here. So creating a change notice, for instance, from ThingWorks and start a workflow in Windchill. So that was the slides. I will now move into the demo part of this session, and I will start by creating an mBOM from an eBOM. So I will use the Lego car that I used during last sessions. I will then create a process plan from the mBOM. I will illustrate some of the operations, and then we'll take a look at the operator user interface. If we have time, let me know, Carolina, if we have time for that. I will also update the eBOM and see how that flows into the downstream processes. So hopefully you can see my my windshield window here. So I have my maybe Carolina, you can just verify that.
Yes, it is looking really good. It's a very nice car.
Yeah. Yeah, I built it myself. So this is the engineering bill of material, and the view here, as you can see, is displaying design. That means that this is the design view of the BOM, which means that it's the eBOM. So I will open this in a separate window, which then allows me to have the eBOM and mBOM side by side. Currently, I don't have an mBOM, so it's empty here, but I have my engineering bill of material, and I have the visualization. If we just wait a second here, and the same thing works here. If I click a part, it will be highlighted in the BOM. If I click a part in the BOM, it will be highlighted in the visualization. So what I'm going to do is right click the top level and say I want a new downstream branch. Based on my configuration now, I will create a manufacturing view of this. So instead of the design view, I will have a manufacturing view. If I'm working with service bill of material, it will display service here. So I'm creating a different view for service, different view for manufacturing. When I do this, I have the option to either just create the manufacturing view of my part and skip all the children here. So if I want to completely restructure the bill of material, I can start from scratch, basically dragging and dropping the parts, or creating new parts here and then dragging and dropping from left to right. Or I can start by copying or duplicating the entire structure, which means that I will have an identical structure to start with. And I will actually do that now. So now I have my mBOM, and as you can see, the parts, since I copied the structure, all the parts have been consumed, which means that all the parts are grayed out like this. But on the mBOM side, we can see it's in shaded mode. So let's imagine that I didn't copy over this part, for instance, or that part has been added after I created my mBOM. So I will simply just remove that part, and we'll see what happens here. So that part simply shows up on this side, which means that this has not been added to my mBOM. So I can click that and then drag that and drop it on top of this one. But I will do a little bit more advanced action here. So I want to create a pre-assembly of my engine. And as you can see here, the engine block, for instance, is directly below the Lego car. But I want to have that and the exhaust pipe and the crankshaft and so on inside my engine pre-assembly. So I will select my Lego car, insert a new part. And as you saw in previous sessions, I have different types of parts based on permissions, of course. If I'm a manufacturing engineer, I will probably not have this long list of parts, but potentially only the manufacturing part. So I'll call it engine pre-assembly. And that is then added to my BOM. As you can see, it doesn't have any children, but what I want to do is then select the engine block, select this part here. Let's see, I want the entire exhaust. So let's grab those. I will cut that from my top level and then right-click my newly created engine pre-assembly and simply paste it there. When I do this, they're by default hidden, but I can click this to display the parts. If my machine works, now, let me refresh there, and there you can see that they're back. But I will actually deselect those so I can see a little bit more what I want to grab here. So I will take that piston and then take the entire crank, and potentially I want that one, and that one should be included in my pre-assembly. So I will cut that. I can drag and drop them here as well, but I think it's easier if it's a long way to scroll, it's easier to do it this way. And then paste it on top of that. So the purpose of this is, of course, that when I produce the Lego car, I simply take one engine assembly from stock. I don't assemble these on the sort of line, the production line for the Lego car, if we imagine that we would do that. So I would have a process plan for the engine pre-assembly, which defines how to assemble this. And then I would have a process plan that describes how I assemble the Lego car. And then I will use this as a sort of a already defined or already assembled component. If I would select the engine block here, since that has a new parent, it could be interesting to know where that is located on the engineering side. So I can right-click the part and say select equivalent part on other side. So even if I restructure it like this, it still has the traceability that this part is this actual part here. And in the same way, if I would select another part here, it will then know where that is located. And this is how it keeps track of the consumption status. So it knows that I have consumed all the parts, and if new parts are introduced on the eBOM side, then I can add those to my mBOM. So I will check these guys in. So what I did now, if we go back here to the overview, this here, this was basically the first step. I'm creating the mBOM from the eBOM, restructuring it, but I'm not defining how I do things. This is what I'm going to do in the process plan. So if I want to create a process plan for the engine pre-assembly, I'm selecting that part. And then I have a process plan tab down here. And then I would have a process plan for the Lego car, of course, to define how that is assembled. So I'm going to create one for the Lego car. Insert new. Give it a name, Lego car process plan. So now I have my process plan, and as you can see, if I select another part, it will be empty here. So it displays the process plan or the process plans if you have multiple process plans for the selected part. And then I will navigate to the information page of the process plan now. As you can see, it's completely empty. I'm going to open the related part. So by creating the process plan, I associated that to the mBOM. So here I have the mBOM, and if I sort on number here, we should have the engine pre-assembly available here. So my task is now to create operations that defines in what order I assemble this. So we have two types in this configuration. We have two types of operation, a regular operation and what we call operation group. So typically in an ERP system, you would not define the operations on, assembly step on the assembly step level, you would have a higher level of operations. So this is what we represent with the operation group. So let's say that you have different stations or work centers in your production line. That could typically be one operation group. But within that work center or that station, you would perform different operations. So these would be the regular ones. So let's add 4 operation groups. And of course, I don't need to know how many I want. I can create them on the fly as well. I can rename these. So let's call it, if I rename operations, order start, assembly 1, visual overview, assembly 2, and so on. So let's zoom out a little bit here, or zoom in. So in the assembly 1, I want to add the actual assembly steps. So let's say I have 5 steps here. And of course, I can rename these as well. So what I'm going to do now is select the parts that I want to assemble in the first step. So I'm selecting these parts, dragging and dropping them onto my first operation. And as you can see, they are hidden from that side. And if I turn on the visualization here, they will show up on this side. And then I probably want that part in the same operation. And if I select that part, I can also, if you take a look at this, in the BOM here, I have 2 plugs. So if I would drag that over to the operation, I would actually get 2, but I want a single one here. So I can either display the BOM with occurrences, as it's called. Then it will split those 2 plugs into 2 rows. Or I can select the operation, select the part, and then say allocate. And then it will simply add only that part and not the second one. So these are the parts that should be assembled in the first step. Then I will add that one and that one. Those should go into the second step. Like that. And then I'm not going to do the entire Lego car here, but I think you get the point that this would be the illustration that describes these parts would then describe how I assemble these 4 parts. And then the second step will be to assemble this and so on. It's also possible to add tools and fixtures and so on. So I'm going to click the plant icon. And here I've created sort of a library with tools and fixtures and work centers and so on. So if we just imagine that we have, or we need a drill to perform this, I will simply drag and drop that onto my operation. And perhaps I need a screwdriver for the second operation here. And of course, if these have a 3D representation in Windchill, then those would show up here as well. In my case, they don't, but yeah, these are actually regular parts. It's a different type of part. So I'm going to minimize the browser there. And if we take a look at this level here, and for each of these operations, I can add additional descriptions, and I can add some formatted text with bullet lists, and do this, and then add a bullet list, and so on. So you can also add documentation to this. So if you have a safety instruction or whatever, you can simply add that to the documentation tab here. You can also define the time required for these operations. And of course, you decide on what level you want to do it. So let's say that the routing in the ERP system may be only defined to this level. So this would be the only thing that we would publish to the ERP system. Then we would probably define the time on this level. But if the ERP system can manage the lower levels, the more detailed levels, we can add the time to these as well. So I'm going to scroll here. Here we have the setup time, the labor time, the processing time. There are more time attributes that you can add, and you can of course remove them from the layout here if you don't use it. So if we take a look at my PowerPoint again, so this was the second step of the process. I have defined the operations. I've allocated the parts. The next step is now to create the illustrations. As I said before, I could have, if I have existing photographs that describes this or images, I can simply add that as documents to my operations. But I can use Creo Illustrate also to generate these illustrations. So I'm simply going to right-click this operation, say New Illustration. Now Windchill generates a 3D model based on these 4 parts and potentially tools and fixtures and things like that. And then it will prompt me to open Creo Illustrate. And I will log in to that. I'm not going to go into detail about Creo Illustrate. We can do that in a separate session. But what we're basically doing here is exploding the parts. So let's say I want to move this guy a little bit that way and this guy there, and then have an explode line, let's say. Let's move this to there, add some explode lines. And then perhaps just to clarify that it's actually that hole that it's going to be inserted in, I can add what we call an inset. Yep, so let's keep it that way. And then I will simply save this. So what Windchill will do now is it will store the 3D representation of this illustration along with an image file. So if I go back to the process plan now and select this operation, I may need to refresh this. We can see that it has added a document to this. This is the image of the illustration, but also the 3D representation. I'm going to create one more illustration here, just so you can see that all the parts that have been previously assembled will automatically be sort of grayed out in Creo Illustrate, so you can more clearly see that what to focus on, basically. So create. So here you can see that the parts that I already assembled are grayed out. I'm going to do this. So my task is now, let's say that the first step here is actually to put these two together. So I will simply do this, add an explode line, and perhaps something like this. But then I want to have another figure where I display how I put these together. So this should be restored, and then I will simply move these guys out like this, add an explode line to that. Oops. Like so. So now I have two figures describing this one and this one. And I will save that. And once it's done, let's see, it's still saving up here. Give it a few more seconds. There we go. So if I now refresh this, I will then have a document associated to this operation as well. So if I right-click my process plan now, and I'm aware that this is not completed, but hopefully you get the idea, I can generate a work instruction. And that generates an HTML page with the images that I've created, the illustrations, along with the parts that are used for that that operation, and the required tools and so on. And in this case, I had two images, as you saw. If I click this, it will actually open that in Creo view. So I can view that in either the image or the 3D. So this is the third step. And as I said in the beginning, all of these steps are associative to one another. So changing the eBOM will update the mBOM, or I can easily identify the parts. And of course, I need to define where it belongs to. Add additional parts to my process plan. But if I modify an operation by adding another part to it, I can simply update the illustration. So everything I've done so far will still be there, but additional parts will show up. The fourth step here is to either use the built-in work instruction as you saw, or what I will show you now is the, let's see, the possibilities that we have with ThingWorks. If this works now, let's see if I had to restart my my computer here before this session. Let's see if it loads. Yes. So what I'm going to show you is an example of a company called Polaris that develops these snowmobiles. And they have configurable products, so they have use options and variants to filter the BOM. We have a process plan that I will show you is one of these what do you call it, suspension systems with the skis and so on. So the process plan looks like this. So this is a pre-assembly where you start by adding that one, and then you have some new parts here and so on. And this can then be published to ThingWorks. So this is ThingWorks is an application or a platform that you can use for many things, but you can use it for connected work cell, where you can define your work orders and then find those, and then all the information that is defined in the process plan can then be displayed here. So here are my work orders. I can view that. I have the assembly steps, which is what you saw here. I can start this. That could then potentially send a request to the ERP system that starts the operations there. And let's see, hopefully this loads now. So here I have my operations. Operation 10 will then be the first step here. And then all of this information is defined in the process plan. I have the parts that are used in that operation. I can say that I'm done with it or that it didn't work. So let's complete that, and then it will move to the second operation. In this case, there's a tool that's connected, so I can simulate the torque, for instance, needed for that. I can say that the torque was that, and then move on to the next step. So defining the process plan, you could basically consume that in different ways. So you don't have to use ThingWorx, but that's a potential that you can do. So what's the time, Carolina? Is it question time or?
It is question time, but I think we can squeeze in Väderstad as well. I think it's a nice addition.
You mean what I said, if we have time?
Yeah.
Yeah. Exactly. Let's see if since I restarted my computer, I just need to log on here again. So what I thought I would do is, let's see if I have my Lego car here.
We can take a question in the meantime.
Yeah, that's good. Good.
Yeah. So we have this question. What are the benefits of managing the mBOM in Windshield compared to managing it in the ERP system?
Yep, that's a good question. And typically, ERP systems, some ERP systems have the support for managing eBOM and mBOM. Some don't. So then you only have one BOM, and that needs to be the mBOM, which the result of that is basically that either engineering needs to create the assembly levels that are needed for manufacturing, or on the manufacturing side, we need to create these, of course, in the ERP system, but there's no connection to the source, so to speak. So you basically need to go into Windshield or whatever PLM system you have and compare them, because the eBOM will change, and you will have, then there will be quite a lot of work with maintaining the mBOM and keeping that up to date. If they have support for this, and some do, as I said, we've actually heard from ERP vendors when they saw what we're actually able to do here with a 3D connection and so on, that it's difficult to compare the possibilities when you have the 3D visualization, because if you imagine that you would define the process plan that I did in the order in which you assemble stuff, if you don't have 3D to see what a part is and what parts should be in what operations, so you end up sitting with the 3D model perhaps, or the 2D drawing, to see what parts should actually go into each operation. So of course, having the 3D and having this sort of digital thread between eBOM, mBOM, and process plan is a huge advantage, I would say. So hopefully that answered the question.
Definitely.
You can. I will just open another assembly here. So if you have another question, we can take that.
Absolutely. So how do you manage multiple production facilities, for example?
Yep, that's a good question as well. So here we have the manufacturing view. and the design view. If you have multiple production facilities, it could be the case that it's often the case that you don't have the same production line, and you may assemble products in different ways. So the mBOM and the process plan is not necessarily identical. Then you could have different views. So it's possible to define plant A view, plant B view, and so on. And based on the same engineering bill of material, you can then create different views for each plant. If, however, the mBOM is identical, you could use the manufacturing view, but it could be the case that some metadata of the parts are different. Then it's possible to define what we call extended data. So to the same part, you can actually associate a metadata object, if you will, that makes it unique for that plant. So let's say it's a make component in one plant, but a buy component in a different plant. Then that information can be different for the different plants. But the structure, you don't have to create and maintain two bill of materials. And of course, if you have 1 or 2 plants, that's doable. But if you have 20 plants, then it will be a challenge to maintain as many BOMs as plants. So that could be a useful feature as well. Yeah, but different views is one option.
Mm.
So maybe I should just do this. So what I'm intending to do is replace this this seat in the eBOM. I did this during last session, but I will just show you how this looks on the manufacturing side. So I'll replace it with this new seat. And if you joined last session, I simply did a mapping between the assembly references here. Don't have to focus on that too much now. I'm just going to do it. So it will check out my top level assembly. If I want to, I can revise that, of course. Now I'm just going to do a simple checkout. Now I have my new seat, and that contains a lot of new parts in it as well. So we'll check that into Windchill, and I will then go to my eBOM. So this is the design view that will then contain my new seat. Yeah, I will open that in. It didn't look like it there. Let's see if it check-in succeeded. It was just a glitch, I think. Let's see here. There we have my new seat, and here I have my old seat. So what I'm going to do is turn off the status of the parts, and then we can see that this seat is missing. I have the option to compare these structures as well, to identify the differences between them, part by part. So here I can identify that this seat is on the upstream side 1, on the downstream side 0. So it highlights that particular part. This seat has 0 on the upstream side, engineering side, and 1 on the downstream side. So I can either see it in the 3D or compare it part by part. So my task is basically to remove this guy and then add the new seat, and I will add that to the top level here. Let's see if I just refresh that quickly. Add that new part. and then the BOMs are up to date again. And of course, if this was used in a process plan, a similar fashion would be used to update the process plan and drag this to the operation where it belongs to. Good. So do we have any more questions?
We do. We actually have a lot of questions, but we only have time for one last one.
Okay.
But Martin, you can reach out to them personally later.
Yeah, for sure.
Great. So the last question is, if you manage the mBOM in Windshield, how do you define when a change is introduced in production?
Yes. So typically, if you have a change process that sort of drives the change, if you don't have the mBOM, of course, you would do all the engineering work in regards to that change. But if you have the mBOM as well, then that can also be included in the change, of course. And if we take a look at, let's see if I have something here. Typically, you would define a sort of phase-in date. When will this part be introduced? A date or a serial number when a part is introduced in production. In the change process, it's possible to define what we call effectivity, which is basically the introduction date or the phase-in date. So and that's how you typically do it in the ERP world as well. You set a date when a new part number should be introduced and so on. And that could be defined manually on the part, but it could also be driven from the change notice. If you have multiple parts that are introduced, you can set that effectivity on all the parts in that change notice. I think that should answer the question. Some companies actually define it in the ERP instead. So we push the mBOM, we push the process plan to ERP, and then in ERP they define the phase-in date. But it's also possible to do in Windshield. More questions?
I think we will save them, and you will get back to them.
Yep.
So I would just like to thank everybody for participating today. And this is the second webinar in the series. So we have the next part coming next Thursday as well. So make sure to sign up to them. It is about how you manage your eBOM to spare part process. So make sure to sign up to that. Link is in the chat. And thank you so much, Martin, for another great presentation. And the Lego car never looked as good as it does now.
No, it will be a Lego car in the sBOM session as well. So yep. Thank you, everyone.
Thank you, everyone. Have a nice day now. Bye.
Bye.